I was asked to make a video going over problem 56 in section 4.2. For those of you who care about the page number, it's 478. And this problem admittedly has a few different things in it, but based on the questions I got, I'm going to kind of alter it slightly, I guess. You're told for 56, write tangent in terms of secant for t in quadrant 2. And the idea is we have an identity for tangent and secant. We have tan squared of, we'll use t because the problem does, plus 1 equals secant squared t. So if I want to write tangent in terms of secant, just solve this for tangent. So subtract the 1, the black's dying, so here. We get tan squared t equals secant squared t minus 1. And now square root both sides to get the tangent by itself. So we get tan of t equals the square root of secant squared t minus 1. But we remember, just going back to say 171 pre-calc and all of that, if I square root the square, think quadratic formula and such, I get a plus or minus here. And then all I really care about is, well, I really only want one answer to this. Should this tangent be positive or negative? And that's entirely based on the quadrant. And as far as definitions go, we've kind of defined tangent, secant, sine, cosine, and all that in different ways. SOHCAHTOA, right triangles, unit circles, stuff like that, points in the plane. Ultimately, the idea is, if we think about the unit circle, or just the regular XY plane in general, we had said, as far as it goes, sine of an angle theta is equal to y over r, where r is the radius, or y over h, the hypotenuse. But on the unit circle, the hypotenuse is just 1, so the sine value on the unit circle is just the y value of the point. Cosine value is the x value. And then by extension, tangent is sine over cosine, which means it's y over x. And again, if I have a point that's not on the unit circle, this is slightly different because I'll have a hypotenuse. But in principle, we can use the idea and kind of combine our idea of the unit circle with our idea of SOHCAHTOA and right triangle trigonometry and figure out what's going on. So if, just to use one we already know, a 45-degree angle, pi over 4. I know that's the point root 2 over 2, root 2 over 2. And I know from right triangles and solving this out, that's x, that's y. This is the sine value. This is the cosine value on the unit circle. But we had said, what if I take this angle down here? This angle going all the way around would be 7 pi over 4. Logically, if the cosine is the x value and the sine is the y value, I just need to find the x and y value of this point, and then I get sine and cosine of the angle 7 pi over 4. But since this is a circle, it's symmetric, it has to have the same x value, root 2 over 2. The y value is below the axis now, so it's negative root 2 over 2. Which means for 7 pi over 4, the cosine is root 2 over 2, the sine is negative root 2 over 2. All we're really doing is looking at this first quadrant here, figuring out the x and y coordinates, and then when I jump to different quadrants, I just say, is x positive or negative there? Is y positive or negative there? That dictates the sign of my trig function. So for this one, the problem in your book, number 56. Suppose t is in quadrant 2. If t is in quadrant 2, it's over here. We know tangent is equal to y over x, sine over cosine. In this quadrant up here, the y value is positive, the x value is to the left of the axis, it's negative. So the tangent will be positive over negative, which makes it negative. So in quadrant 2, I need the negative there. If I do the same thing, but for the second part of this problem, it says t is in quadrant 4. That means I'm over here. Again, I look. Tangent is y over x. In quadrant 4, the x is positive, it's to the right. The y is negative, it's below. It's negative over positive, which is negative again. So for this one, it's negative. If we're keeping up, if t was in quadrant 3, x is negative, y is negative, then the tangent would be positive. So again, one thing you can do, and you can look at it in the back of your book. If you look at the unit circle on the inside back cover, which I guess is different for those of you online, but wherever it is in the ebook online on the inside back cover, where it lists out the unit circle, maybe kind of jot it down, or on separate paper, write it out. Sine is the y value, cosine is the x value. So looking at the different quadrants for the unit circle, right here, say I'm in this quadrant. To shortcut this, we'll have sine, cosine, and tangent. I'll leave off the reciprocals. In this quadrant right here is sine, positive or negative. Sine is the y value. In this quadrant, we're above the axis, so sine is positive. Cosine is the x value. This quadrant, we're to the left of the axis, so cosine is negative. Tangent is the quotient of these two. Positive divided by negative is negative. And you can do the same thing for each quadrant. Look at if x is positive or negative, if y is positive or negative, and then by extension, if the quotient of x and y is positive or negative. That should help you kind of grasp, okay, when is my trig function positive? When is it negative? Literally just using your understanding of the xy axis. Where is x positive? Where is x negative? If another video going through even more of this would be beneficial, just let me know. Not a problem.